Hello everybody, welcome to the lesson for geometry on 4.1. It can be found in these pages in your geometry book, and for my students specifically for full credit for the notes, you're going to copy down what you see and turn that in on the lecture due date for full credit. Alright, so here's some vocabulary you should know for this lesson. Looks like quite a bit, but it's actually a lot of really easy terms, a lot of things you probably know from classes before even taking geometry. We should know what all these mean by the time we're done. So just read this note down here. You don't have to write all these down right now, but you should know all those by the time you're done. And as always, make sure you're using the extra examples in your book. There's a lot of extra examples in the book that can help. I'm going through a few of them here together with you as well. So let's start by doing this, taking triangles and classifying them by their sides. So I'm going to use some of my shape tools. I've got some pretty cool shape tools. If you have a straight edge or a ruler, you could use that to help you draw some straight lines here. But I'm going to just use my tools that I have here, and I'll draw, first of all, one that looks kind of like this. You'll notice I'm trying to make all the sides look about the same in this one. So I'll take that. That is one of them. I'll move that over here. There we go. Another possibility that we have is back to the shape tool here. Okay, I got my triangle. We could have something that looks like this instead. So maybe you notice something interesting about that. Maybe not yet, but something that's not quite just plain old normal, but something more specific about these two sides in particular. And then also let's do one like this. So we'll say there, and we'll say something like that, and something like that. Okay, so that's a little more than a 90-degree angle. Nothing too special about that one. And I'm going to add some extra information here to the pictures that will help us determine what these kinds are. Oh, I wanted that to be, I'm going to use red here just to help it stand out a little better. So let's say I put markings on all three of those there. What would that make that? Well, these are all the same. All their sides are the same. That's a special name. We call those equilateral triangles. So this is an equilateral. The equal part meaning equal, the lateral referring to their sides. So equilateral is this type of triangle. This one, let's say we had, I'll use a different color just so you know that I'm not saying this over here is congruent to this one. I'm talking about this as a separate triangle, kind of standing alone here. So this one you have two sides that are the same, and this is called an isosceles triangle. We'll learn more about this later, but an isosceles triangle has at least two sides being the same, and an equilateral triangle has all three sides being the same. And then on this one, I'm going to say that none of the sides are the same. So I'm not going to put any markings on this one at all. I am just going to say that they're not the same, just telling you that. So this one, it has a special name. It's called scalene. A scalene triangle has no equal sides. Nothing very special about that one. Alright, so let's also classify triangles by their angles. And before we move on, let's just write that down under here too. This had three congruent sides, equilateral triangles, and isosceles had at least two congruent sides. So at least two congruent sides, and scalene had no congruent sides. Okay. Now I'm ready to move on. Alright, so let's say let's draw some more triangles here. There we go. I'll use that one. And let me go back to black just a second. There we go. So let's say now classifying them by their angles instead of by their sides. We're going to draw 4 different pictures for this one. You'll notice on this one I'm trying my best to make sure that none of the angles are bigger than 90 degrees. Well, what does that mean? If none of them are bigger than 90 degrees, we'll get there in a second. Let me connect those a little better. There we go. Alright, so this one, none are bigger than 90 degrees. This next one, I'm going to use my shape tool again, and this next one will look, what's going on there? I don't know. Looks very much like the equilateral triangle. Let me move this around. Get rid of that. There we go. Alright, so this one, very much like the equilateral triangle, but now we're classifying it by the angles. So we're saying something about these three angles in this case. Another one is where you have a right angle. I don't know if I have a right triangle tool here. I don't see anything, so I'll just draw individual lines. So I'll say that, and I'll say that one's the right angle. Connect that to there. Okay, and then the last one, you're going to have one pretty darn big angle, something like, let's go like this, and so you'll notice this angle right here that I'm about to complete, that one is bigger than 90. That one's bigger than 90. Let me just move this a little bit if I can. There we go, so it connects a little nicer looking. Alright, so let's go through these one at a time. So this one, you had all the angles being less than 90. All the angles less than 90. This is an acute triangle. Acute triangle. Because acute angles are all less than 90, so if all three are less than 90, then you have an acute triangle. This has three, so acute. This has three acute angles. For this one, you can actually say, or well, let's put this in here, that one, and that one, those are all congruent. And so, if that's the case, this is something we call an equiangular triangle. Equiangular. And we'll learn more about equilateral and equiangular. If one is equilateral, then we can also assume it's equiangular, and vice versa. They end up going together. But this has three congruent angles. Now, we don't know we don't know what all the angles in a triangle add up to, but they're all going to be the same. We'll get to that in just a second. And then, I'll go with purple here. This one, I'm saying there is a right angle in the corner right there. So this is a right triangle. We've done plenty of stuff with right triangles before. You already know the Pythagorean theorem. But what makes it a right triangle? Well, there's one right angle. There's one right angle. And then these sides have special names. This is called the hypotenuse. And it's spelled like that. So that's the hypotenuse. And then these two are called the legs. These two are called the legs. The legs are there. The legs are adjacent to each other, so adjacent legs right here, they touch each other. They share this common vertex, and then the hypotenuse is across from the right angle. The hypotenuse is always across from the right angle, and it's also always the longest side. So that's the hypotenuse. These are the legs. And then this last one, this has an obtuse angle right here. It has an angle greater than 90 degrees. Anytime you have a triangle like that, we call it an obtuse triangle. So this has one obtuse angle. And we'll find out a little bit more later too that, I'll just say it right now though, that a right triangle, it can only have one right angle. It's not possible for a triangle, at least in Euclidean geometry, not possible for a triangle to have more than one right angle, and likewise it's not possible for a triangle to have more than one obtuse angle right here. So here's the obtuse angle right there. I'll make a little arrow there and say, hey, it's that one. That one's the obtuse angle in this case. Okay, moving on to this. We're going to classify a couple triangles. I'll get to this in a second kind of a funny little comic there, but at least I think it's funny as your geometry teacher. If you don't think it's funny, too bad. Sorry you don't think it's funny. Let's see, so let me draw a couple triangles here. We'll do a couple examples in one with this one. I'll go with the shape tool instead. Okay, so I'm going to go and do something like that for this first one. I'll move that over just a little bit. There we go, and then this other one I will just draw. I'll go back to this and just draw some lines. I'll connect these lines. Something more like this. Let me make that a little more clear. I'm going to say this one and this one are not the same length. So I'm going to just move that over here a little bit. There we go. Okay. So classify these, and I'm going to add some extra information to the picture here. So I'm going to say that this and this side are congruent. I'm going to tell you that this is 50 degrees. I'm going to tell you that this is 50 degrees. And I'm going to tell you that this one's 80 degrees. And you may notice something. If you add up these three angles, you get 180. And we'll talk about if that's always true in just a moment or two. So this is, if we look at this, I go back to my drawings back here. By the sides, well, this is going to be, there's two sides, at least two sides that are the same. So that's going to be isosceles. And by the angles, I notice, hey, these two angles are the same. So I notice this one and this one are the same. And I look at all of these and they're all acute angles. Nothing is bigger than 90. And so I go back to this and I would say, okay, 3 acute angles, that's an acute triangle as well. So we had isosceles and acute, and generally we'll say the angles first and then we'll say the sides after that. So this is an acute isosceles triangle. And we have a symbol for the triangle. For any triangle, it's just a miniature triangle like that we can use as our shorthand for that. So let's box in that. That's my final answer. Do that there. And so this last one, I'm going to give you some angle measures in here. Let's say this is, and remember you can't trust what the picture looks like necessarily, but you trust the numbers that I give you. Let's say this is 35 degrees, and let's say that this angle right here is, we'll go with 15 degrees. That would mean this one would have to be 35 plus 15 is 50. What's left over would be 130 degrees for that. And I'm saying that I can't put any tick marks on here. None of these are the same with respect to each other. So I look at all that and nothing's the same, therefore it's going to be scaling, no congruent sides. And then in terms of angles, you don't have a right angle, you do have acute angles, but you only have two of them. You have one obtuse angle. So you do have an obtuse angle, the one that's bigger than 90, this 130 is obtuse. Therefore this one would be, we would classify as an obtuse scaling triangle. An obtuse scaling triangle. And then let's see if you get the joke up here. You might not think it's funny again, but I think it's hilarious as a math teacher. So I met a cute girl the other day. Cute, get it? Okay, Mr. Wagner, that's funny. Oh man, did you ask her out? I need to work out the right angle, if you know what. Seriously, stop with the triangle jokes. Oh, hypotenuse, hypotenuse. Yeah, that's hypotenuse, get it? Oh, okay, that's hilarious. We didn't see it there. It's the pot and it's the news. Oh boy, okay. That's stupid, Mr. Wagner. No, that's hilarious. Moving on. Interior and exterior angles. Let me draw another picture. This one will go something like something like this. So we're going to extend the sides out a little bit. I'm going to make an arrow right there. And then this one, same sort of idea. Make a little arrow right here. And this is going to go, oops, I'll move that in just a second. I'll have an arrow right there. And I'll just move this down just a little bit so it touches there. And now I've formed a triangle. And we're going to label some of these things here. No, not. There we go. There we go. Okay, so some of these are interior angles and some are exterior angles. Let's go with green here being my interior angles. So I'm just going to put some dots in the corner. That's not green. Go and do that. Green. There we go. So this one, and this one. I'm not saying any of these are the same. They could be. They might be congruent to each other, and they might not. But I'm just saying that I'm referring to this angle right here, this one, and this one without labeling a bunch of letters. This way, all three of these would be interior angles. They're on the inside or on the interior of the triangle that I've drawn here. So interior angles is going to be all the ones you see here. So interior, this one's interior, this one's interior, this one's interior. And then exterior angles are the ones on the outside. So the ones that are formed if you continue these lines out, the ray continues in this direction. It's going to be, I'll draw this in red here, it would be this one. So the angle from here to here. It would be this one, angle from here to here, and it would be this one. These three are what we would call the exterior angles. So the exterior angles. And we have some theorems about both interior angles and exterior angles for triangles, so that's why we're defining what they are right now. These are exterior angles all here. Okay, so interior angles, exterior angles. Now that we know what those are, now we can do these next couple of theorems. So the triangle sum theorem, or theorem 4.1, I'd rather have you call it the triangle sum theorem than theorem 4.1. It says this, that the sum meaning you add them all together, so the sum of the measures of the interior angles, I'll abbreviate angles like that, some of the measures of the interior angles for any triangle is 180 degrees. Now there's actually something called hyperbolic geometry where this isn't true. You can come up with different postulates to start and prove totally different things, but we're doing Euclidean geometry. We can assume that this is always going to be true in the type of geometry that we're doing. So let me draw a triangle to help us make sense of what I mean by that, or to have a picture to look at to kind of show what I mean by this. So I would say something like this, just any old triangle. I'm not drawing anything special, any special type of triangle here. So something like that, and that. Slide that down just a little bit. Come on. Oh, wrong one. There we go. Okay. And so let's call this A, B, and C. So if that's labeled like that, you would say the measure of A plus the measure, what is that? I'm not very happy with that. Let me change. Just erase that little thing. That's a plus sign. It doesn't look like a plus sign the way it was. Plus, there we go, that's better. Measure of A plus measure of B plus the measure of C equals 180. That's the big thing to remember here. So any triangle you take, any triangle you could draw. I could have a super tall skinny one, I could have a obtuse one, a cute one, I could have any triangle at all. The three angles on the inside, the interior, are always going to add up to 180. Okay, that's the triangle sum theorem. And then we have the exterior angle theorem. I'll draw another triangle to go along with that. Okay, we'll have something like this, something like this. This one I'm going to extend out a little farther and keep going with a ray there, and something like this. So I'm just drawing in one exterior angle of the three. I could draw more rays this way and this way and this way, and then add all three exterior angles, but just going to refer to this one for right now. So let's label these points. We'll call this A here, we'll call this B right here, we'll call this C down here, and this one we're going to call angle 1. So the exterior angle theorem 4.2, this says that the measure of angle 1 equals the measure of angle A plus the measure of angle B. Now if you want to see the proof of that, why that actually is true, you could look on page 196 in your books. They prove why it's true, but I'll just kind of verbally explain why this actually works out. If you can understand why something is what it is instead of trying to memorize it, that always works better in math. Don't try to memorize something that you can logically come up with in your mind. Then you don't really have to memorize it. So why does this hold? Why is this true? Well, I'll draw some marks in here. So I'm saying here's A and B, the two green angles right there. They have to add up to this red angle right here, because, well, think about this. We just said that the angles in any triangle add up to 180. Okay, so that means A plus B plus this one C. I guess you would have to say ACB, because that would, C wouldn't be as straightforward, C wouldn't be as specific as you would need to be. So you just have to say angle ACB or BCA instead. So this one plus this one plus this one equals 180. And I also know that this one plus this one equals 180. They form a linear pair. So if I were to take this part away from both the green and that one here, and both from and take that away from this one here, I'm taking away C. What's left over has to equal each other. So this one and this one added together have to equal that one, because I took away both parts, or from both parts I took away that angle. So that's kind of my verbal explanation of that. If you can think about that and come up with that without memorizing it, much easier to come up with that on a quiz or a test where you'd have to utilize that theorem. So let's do an example now where we use this theorem, we put it into practice. So let's draw another triangle, something like this. I'll have my exterior angle go out this way instead this time. That's totally fine, no big deal. And I'm going to try to draw this angle so it looks a little bigger. It doesn't look bigger than 90 to me, but maybe just a little bit, but we're going to assume that it is. So I'm going to say that this is 110 degrees right here. So again, we trust the numbers that are in there, not necessarily what the picture looks like itself. Let's call that x degrees. And I'm going to call this one 4x minus 7 degrees. So if we look at this theorem, I'll color code some things here too. This would be, this time, here's my green part, here's my green part. Just like I had here and here. Those are my two interior angles that are on the opposite side of the exterior angle in question. So this red one here is matching up with this one in this picture. So I'm saying this one would have to add, or would have to equal the sum of these two by this theorem. So we write this out. We could come up with the equation, use the exterior angles theorem, and say that x plus 110 equals 4x minus 7. If you had to give a reason for that, you would just say that's the exterior angles theorem. And then from there, it's a hopefully simple algebra problem for you. So you would take this, we would subtract subtract x from both sides. And if you wanted to do this all in one step, you could do this in one step. So you're going to move this over here, the x's will all be over here, and then you could add 7. If you wanted to do this in 2 steps, you can go ahead and do that in 2 steps too. So I'm going to move all the x's over to the right side, I'm going to move the regular numbers over to the left side. This will cancel out here and here, this will cancel out here and here. I'm left with 117 equals, this will be 3x, 4x minus, it's like a 1x, and then divide now by 3 to finish it up. So you get x equals 39, or 39 equals x. Now if they said that you just had to solve for x, you'd be done. If they said find the measure of the exterior angle, let's do that. So we take this, what would we do? We'd plug it back in. We plug it back in right here. So the measure of the exterior angle has measure, and we plug in 4 times 39 minus 7. 4 times 39 ends up being 156, and then 156 minus 7 is 149 degrees. So if they asked you for a little bit more than just solving for x, then you would plug it back in, do something like that. We would know that this one right here would be 39 degrees because it's the same as just plain old x. We could also check our answer real quick by plugging this back in. So this would be 39, this would be 149. That would make this one 31 because these two plus this one has to add up to 180. And if this is 31 and this is 149, that also adds to 180. So a nice way to check our answer to know for certain that we did it right. And then one last page here. A corollary to a theorem is, and let's finish this thought out. So the corollary to a theorem is a statement that can be easily proved using the theorem. And so there's this corollary on page 197 to the triangle sum theorem. If you look on that page in your book, we know that the angles in a triangle, any triangle, add to 180. So if one of those angles was a right angle, in other words, if one of those angles was 90 degrees, then the other two would have to add up to 90 degrees as well. So we're going to use that idea here for this last one. Looks like I can move this up a little bit. And let's draw a right triangle this time. So let's draw a right triangle. Use that and go. The right triangle kind of looks like this. And let's say there's 90 degrees right there. So it's a right triangle. This is going to be 3x degrees. 3x degrees right there. And this one I'm going to say is x degrees. And I'm going to give these vertices. Vertices is plural for vertex. Vertex is just one. So these vertices I'll call H, A, and T. So triangle hat here. We're going to use the corollary. Using the corollary on page 197. So using the corollary on page 197, we can come up with the fact that, well, we could say 90 plus 3x plus x equals 180, or we can just use the corollary and say 3x plus x equals 90. We save ourselves a step like that. So 3x plus x equals 90. Put these together, and you got 4x, combine like terms, and then from there just divide by 4 to get x by itself. So x equals, and that doesn't turn out to be a real nice number, but you could say it's 45 over 2, you could say 20 22.5, or you could say 22.5. I think 22.5 or 22.5 make the most sense. So x is going to be 22.5. So let's say I asked you not to just stop there and solve for x, but to actually find the measure of angle h and find the measure of angle t. All we would need to do is take that, plug it back in. So the angle t is real easy. That's just the same thing. So it's just 22.5, and measure of angle h is just 3 times that number. So 3 times 22.5, which is 67.5. My apologies, I'm getting over being sick, so sorry for the cough there. But we could check this very easily too. Just add these two together. Do you get 90 like you should? Yes, you do. So if you add those, and if you add all three, you get 180 just like you should. So hopefully you found that helpful. Again, there's extra examples in your book to look at that are very similar to help you with your homework. I guess I'll see you guys around. I'll see you later, and hopefully the lesson goes well for you. Let me know if you have any questions in class. Thanks.